Welcome to 3 Degree Weather. I am meteorologist Emmanuel Rivera, and I'm joined by two great meteorologists with me, starting with Andres Sosa.
Hi, I'm meteorologist Andres Sosa. I run the Weather Risk page, and yes, I'm wearing pants.
Good to know. And we are also joined by meteorologist Luis Dieguez.
Greetings, everyone. Happy to see you again, Emmanuel. Same with you, Andres. I run 2580 Weather on Instagram. Feel free to give me a follow, and I am wearing shorts.
Thank you, Luis. And I'm, like I said, meteorologist Emmanuel Rivera. And you can follow me at Where the Skies Are Blue on Instagram, and I am wearing jeans. Let's get started to today's topic. And today we will be talking about different weather events around the world that happened in recent memory, probably 1 year ago, 2 years ago, or happens very frequently, annually. And let's get right into it. So, Andres, meteorologist Andres Sosa, what is your weather topic today?
Hello, I want to paint a picture for you guys, and I brought a little history book here to read you guys a story. I want you to close your eyes and imagine a distant storm, and it's just far away, maybe 10 or so miles. So, it's about the time it takes you to get to work, sure. And you see beautiful little drops of rain here and there, and you feel at peace, all at zen. But now replace every single drop of water with lightning. And that's what we're talking about today. We're talking about the Catatumbo lightning that occurs in Lake Maracaibo, Venezuela. So, if you don't know, Lake Maracaibo is a lake in the northwestern part of Venezuela. Venezuela is the northern country, the northernmost country in South America, South America being the continent south of North America. So now you got your situation like sorted out. So, what does Catatumbo mean? Catatumbo stands for House of Thunder. Why? So there is this urban myth and legends that this lightning strike is sort of mystical. It doesn't seem to make a sound, and the mythology says that it's never killed anybody. And I'm here to break that myth and tell you the reality. It does make sound, and it has killed people. So it is this beautiful spectacle, and I'm going to show you real quick if the host can allow me to share my screen. That I'm going to show you a couple of pictures of this lightning storm because it is really a spectacle. So it is you can see these lightning storms from one of the coasts of Lake Maracaibo, and it occurs because you have warm air from the Caribbean on one side, and then you have constant hitting the side of a mountain that forces this air to go upwards. And this lightning storm, okay, occurs for the majority of the year. Okay, it occurs for up to 10 hours every single day and for up to, I believe, 140 to 160 nights a year from May to November. And it is beautiful. Let me see if I can share my screen. I can. Thank you, Coach, for
Awesome.
letting me
You're
letting me
welcome.
do this. So,
Um, Before you continue, I just want to point out real quick that we are trying something new. I did go through the screen sharing process right now. I hope it wasn't on the recording, but if it is, just bear with us, please. And continue, Andres, please.
yes. So, right here, you can see this beautiful lightning strike, or lightning strikes rather, and you can see that the reason this storm occurs is you have all this air. It forces right here next to a mountain. It forces this air to go up, and all of a sudden you get this cooling, the condensing, and you get these cumulonimbus clouds, which is where we get thunderstorms from. Now, what I forgot where I was going. So, now, I want to ask you guys a question. I know I said the amount of nights that this lightning storm occurs, but I want to ask you how many lightning strikes do you think occur per minute? Now, don't let this picture deceive you. This is one of the most popular pictures of the event, but you also have this effect, this image right here, where this is one of the coasts, and these people, the Bari people, get to live and experience this just outside of their homes. Now, this lightning, while beautiful and spectacle, they say that they don't hear sounds, and that is because the lightning is actually so far away. You don't the sound is not strong enough to travel all the way to where they are located. So, based off these images, this one and this one, how many lightning strikes do you guys think occur per minute?
Lewis, I'm gonna let you go ahead and take a jab at that question.
Oh, believe me, I will take an educated guess as to how many lightning strikes occur in 60 seconds. If I had to
Yes,
throw a dart at the wall, I would say a little less than 100, 80, 90 bracket.
80, 90 bracket. Okay,
Okay.
okay, that is a guess. That is a guess, and those are numbers that you said. Emmanuel,
Lewis, I think that's an insane number. I'm gonna guess a little bit lower, probably like around 30 volts.
okay. So what you guys said was a lot of like a very high number. It's kind of like you're trying to kill these people. And since I'm from Venezuela, it kind of feels a little racist. I'm not gonna lie. I'm kidding. So, the actual number is between 60 to 40 lightning strikes per minute. To give you an idea, that number is like in the whole time that I've been presenting, which I would say is maybe 4-ish minutes, we would see 120 lightning strikes. And that number is insane. Now, to talk about these storms a little bit and why they are so predominant almost every single night out of the year. Um, the reason why they get fed this constant avenue of moisture is because they're located near the ITCZ, the oh shoot, what's it called? The intratropical convergence zone. Sorry about that. Now this is because of the planet rotating. All of the water in the atmosphere gets focused in near the equator, and this line across the planet it shifts and goes northwards and southwards throughout the year. And it would feed this storm system, and it constantly offers a fresh supply of moisture. And this is why people living in the cities like this get to see this beautiful display of Mother Nature's power every single night. That being said, it is susceptible, like many things, it's a delicate balance. So it is susceptible to the effects of El Nino and La Nina. When we have La Nina, we get more Atlantic hurricanes. But when we get El Nino, we don't get a lot of Atlantic hurricanes because the way that this works is that we lose some moisture activity here in the Atlantic Ocean. And these storms are susceptible to that. I might not have all my data correct on that explanation, so don't take that as gospel. But during a very severe drought caused by El Nino, the everlasting lightning storm, which is its canonical name, lost its we lost it for several months of the year in 2010, and there were concerns that this storm would never come up again, but fortunately, it lived up to its name and it eventually came back and it continues to mesmerize people to this day.
Wow.
Thank you guys so much for coming to my TED Talk. I will be taking some of your questions.
Wow, that's a beautiful event. Lewis, if you have any questions, go ahead.
I have an excellent question for Andres here.
Um,
So, would you say this is a glorified version of Heat Lightning?
I could definitely say that. I am not too familiar with heat lightning, but I'm going to take a crack at it. Feel free to correct me if I'm wrong. Heat lightning is lightning that occurs so far away that you can't audibly hear the sound of it. But when meteorologists warn people to stay indoors because of lightning, it's because if they get near heat lightning, it's usually what will kill people.
Yeah, every once in a while you get these bolts out of the blue. The rule of thumb is if you can hear it, it's close enough to where you can be struck. And you're correct on the heat lightning concept as well. It is basically lightning that is too far away for you to hear the thunderclap from it.
Well,
And
the way you did that was amazing. I didn't hear the clap. I was like, whoa.
Wow, okay.
and Lewis, can you remind us the phrase? Something like if you hear lightning, stay
Ah,
indoors.
okay.
What was it again?
This is a terrific campaign put forth by the National Weather Service. They like to say that if thunder roars, go
Stay
indoors.
indoors or go indoors. My bad. Awesome. And we're
Just run
gonna
indoors.
run indoors. We're gonna move on from this beautiful weather event. Thank you, Andy, for showing us the Catatumbo lightning. Did I say that right?
Catatumbo. Catatumbo.
Catatumbo, my bad.
Yeah.
My bad. Thank you for
This
showing us that Catatumbo lightning. Lewis, you're up. What's your weather event?
All right. So, the phenomenon that I'm going to spend the next few minutes talking about is something referred to by many Spanish meteorologists as the Dana phenomenon. DANA is an acronym. It basically means, for the Spanish speakers out there, I will say it in their language and then I will translate it to our English speakers. DANA is the acronym for Depresión Aislada en Niveles Altos. The English translation of that is an isolated area of low pressure in the upper levels of our atmosphere. So last year, we're rewinding the clock to October. An event that same event unfolded in Spain. So if we're going to take this graphic in full here, I would like to believe that I have the ability to share my screen as well, and hopefully it goes very smoothly.
hey.
There we are, perfect. Okay, so all right. First of all, let's get oriented here because there's just a lot to dive into. We have the jet stream on a yearly basis. That is a narrow current of strong winds. And it steers these mid-latitude cyclones from one end of the earth to the other. Sometimes they strengthen, sometimes they weaken, sometimes they maintain their intensity. And as we get later and later into the calendar year, that zonal jet stream, which is basically the sciencey term to describe a horizontally flowing jet stream, steers these mid-latitude cyclones into the direction of Europe. Every once in a while, one of these areas of low pressure detaches from the jet stream. And that could happen for a myriad of reasons here, some that I will probably bring up a little bit later on. But the point is that in late October, right around Halloween, we saw an area of low pressure detach from the jet stream. This happens, it happens every couple of years. It's not out of the ordinary. Typically, what they do is that they go over the Iberian Peninsula, which is Portugal and Spain. They cross the Pyrenean region, which is the geographical border of France and Spain. And ideally, you would like for that low to continue to go into the Mediterranean because that means that it wouldn't stall out and cause a problem. This one unfortunately stalled. And it was just a volatile setup. It was arguably a worst case scenario for Spain because, as you can see in the graphic, we had two dueling areas of high pressure pretty much working against it. We know that high pressure flows clockwise. So with my cursor here, I'm going to walk you through it. You have a high pressure heat dome over the Saharan desert just to the south of that low. So that high is, not only trying to push it deeper into the Mediterranean, it is also fueling it with warm rising air. So that low is trying to get into Italy, trying to get into parts of Eastern Europe, but unfortunately it is not doing that because you have a neighboring high pressure cell to the north of Spain, over France and in parts of the Atlantic. Basically, it repels, it cancels out, and when that happens, the steering currents collapse. Can't go anywhere. And in similar fashion to Hurricane Harvey, we have an area of low pressure of any kind just raining itself out. It's not weakening anytime soon, not until it will run in an atmosphere where it weakens, so it's dumping copious amounts of rainfall, causing flash flooding. And to add to that, because of the fact that this area of low pressure is what's called a cold core, it is able to generate the kind of instability that can create severe weather. So heavier rain, more potent thunderstorms, some wind, even a couple of tornadoes in here. One final thing before we move on to the next graphic. There is a moisture plume from the Atlantic that is also fueling this. Waters in the Atlantic at this time last year, or not at this time, rather in October of last year. My apologies on that. That was helping keep the system in check. And there were rainfall rates to the point where it was 2 or 3 inches per hour. And when you're talking about that much rain, more inches than hours, you know what happens when it rains too much in a certain place. You get flash flooding, bridges get breached, communities at risk, and lots of fatalities, unfortunately, which we will touch on that a little bit later. All right, moving on to the next graphic. This is what it looked like on the water vapor satellite presentation. Moisture plume, you can clearly see it there. And this is, by the way, courtesy of the chief meteorologist at the NBC affiliate in Tampa, Jeff Berardelli. He pieced this together brilliantly. There you see the spin over the Iberian Peninsula. The plume clearly is evident. It is going over the Cape Verdes, over the shoulder of Africa, and it's just fueling it. The next slide is the worst of the convection. As I alluded to just moments ago, we had rainfall rates of 2 to 3 inches per hour, right in the heart of Valencia, right in the heart of adjacent communities. And rainfall totals were essentially over a foot of rain in most locations in the parts of East Central Spain. Valencia didn't get the worst of it, but because it is an urbanized community, a lot of the fatalities happen over there, somewhere in the neighborhood of over 200 to 230 people unfortunately perished in those 2 days between the 28th of October to the 30th of October, just before Halloween. And I will add one more thing before we move on to Emmanuel. This is becoming more common because of a warming environment. Aside from the fact that the Earth is getting warmer, the reason that people refer to this crisis as climate change is because the weather patterns are weakening. And in a warming environment, as climate change continues to get worse, the jet stream is getting weaker, and it is becoming more commonplace for these same cutoff flows to get detached at any place at any time. And because there are no steering currents, it can just do whatever it wants. And in this particular case, it rained itself out over Spain, horrific flooding. It was the third time, I believe, in the last 60 years that something like this had happened. But it is certainly the most high profile one because it is happening at a time where technology is modern. Meteorologists are supposed to have the best model data. And this pretty much came without warning. Very few people knew that this was even a possibility.
That is crazy. 19 inches of rain.
Oh, yeah.
Wow.
It is, for perspective here, I mean, that's a high number. I am not saying anything to minimize what happened here, but in Fort Lauderdale, a number of years ago, back in April of 2023, we had 26 inches of rainfall in about 12 hours. So if it can happen in Spain, it can happen here in South Florida. The setup was not identical to this. It was a different setup. We had a stationary front that stalled over the area, and it's because we were stuck in the more humid side of that boundary, it didn't stop raining, and that's why we saw the flooding in Fort Lauderdale and the gas shortages that came after that here. But nearly 20 inches of rain, that, my friends, is as devastating as it gets here. And the images out of Spain, the flash flooding, the tragedies are just unimaginable.
I have a question for you, Professor.
Sure.
Did the geography have anything to do with it? Because I know that what makes Florida specifically like rain events dangerous is that we're primarily flat. So any little bump that like in the topography, like that's all of a sudden like a source for a puddle. And like we've had incidents with the airport, Fort Lauderdale Airport, getting flooded, I think just a couple of years ago. So I'm curious if you know how the topography here in Valencia like played a role in just the disaster element.
You know, urbanization absolutely played a role into it. This is an area, a lot of cities in Spain are like this, especially along the coast. You have a lot of impervious surfaces that are alluvial, they are slightly raised, you have higher elevation, so that makes it easier for water and the runoff to just flow into these communities. People live adjacent to these mountain ranges, and they never think that
Yeah.
it's going to happen because it rarely happens, but in this particular case it did. And to your point, topography is key here.
Yeah. I would imagine that it doesn't take a lot of like it just takes a couple inches to start moving like a vehicle, for example. So I can only imagine having an living in an incline like that and just 19 inches of rain just constantly coming down at you. Like that would catch anyone outside by surprise.
Oh
Wow.
yeah.
Great
Uh,
presentation.
Oh, thank you
Lewis,
so much.
Lewis, I do have one last question for you.
Sure.
If he can very briefly, uh, earlier this week, or yeah, I believe it was this week, Texas got hit by a lot of flooding. Sadly, a lot of fatalities occurred. How would you relate this, the event you're talking to what happened in Texas? Are there any correlations? What would you say about it?
Uh, there is a correlation in the sense of that areas of low pressure had something to do with this.
Yeah.
Uh, so in the case of the flooding that happened in Kerrville and in Hill County, Texas, I believe that is the name of the county. Here's how it played out. We had Tropical Storm Barry dissipate over the mountains of Mexico, but there was still some lingering moisture associated with it. Even though the cloud cover fizzles out, the moisture stays in place from the surface all the way up to the upper levels of the atmosphere. So all of that headed into the direction of central Texas. But on the other side, there was a separate component. We had a mesoscale feature coming in from the southwestern United States, right around the border. Both of them converged, and that basically fueled all of the convection capable of producing the horrific
If
flash flooding.
Can I ask you real quick, for anyone in the audience that doesn't know what convergence, divergence means, can you explain like simply
Con-
what it means?
Convergence is air coming together. When air comes together, it rises. And then you get all the thunderstorms, all the moisture. And divergence is the separation. So in an area of low pressure, there is convergence. In an area of high pressure where conditions are tranquil, drier, it's divergence, sinking air.
Yeah. And that occurs because the atmosphere it technically acts as a fluid. And that might not be something that we're accustomed to thinking about, but being a fluid means that it doesn't allow itself to have any holes in it. So when it converges and moves away, diverges and moves away, air from above has to come in and fill in that space, and that feeds into the system. It keeps diverging away and away and away, and that's what creates it like air masses. I mean, and the same thing with convergence. Like once you have something in, all of a sudden, all that space that moved in one direction has to be filled in by other bits of air as well. Thank you for that
Absolutely.
explanation. It was
Uh,
great, and I think
uh,
that like audience would help tremendously
uh,
understanding.
Absolutely. I think the atmosphere as a whole is like a giant puzzle piece or a giant puzzle. There are so many pieces that you connect, and every region on Earth has some sort of air mass.
Awesome. Well, I don't know if you finished explaining the Texas
Yeah,
storm.
that's that again. We're Tropical Storm Barry dissipated, and the mesoscale feature crossed its path. They came together, and we saw just horrific flash flooding. I believe in about 45 minutes, the water levels rose because of that rain from 30 to 30 feet. It
Yeah.
was in a matter of less than an hour, and the death toll at this point it's actually getting really close to the same amount of people that died in Spain because of these same floods.
Wow. Yeah, that's just
Yeah,
awful. Um, and on this, I think the right word is somber note, I would like to pivot to my topic. Um, Sadly, I would like to correlate my topic with, how can I put this? It's just a lack of a lack of a proper warning system in place. I believe Texas just wasn't prepared, at least those counties, and I do think that it was also the timing at which it occurred. It was early in the morning. People just weren't paying attention, and it was hard to really get warnings across. Um, and I want to correlate that the importance of warnings to my topic right here. So mine is very similar to Lewis's. It is a Mediterranean low pressure, a cutoff low like Lewis's, that formed over Turkey in 2023, and it started off like another cutoff low. It poured down rain in Turkey and some of the coastal areas. There was a little bit of damage. I know there was an area, a campsite or bungalow area where some people were swept away by the water, and sadly that did cause a few fatalities. It moved over towards Bulgaria and Greece, where it stalled over Greece, and it was able to gain a lot of energy from that. 2023 featured a huge amount of warmth in Europe and in the Mediterranean. The warm water, the sea surface temperatures in the Mediterranean were extremely high for this year. The way this occurred, this low pressure, this cutoff low, it stalled over Greece and it caused a tremendous amount of flooding. I believe there were accounts of around 40 inches of flooding in some places, which is a insane amount. Um,
Yeah.
and
Wow.
sadly, this isn't the worst from the storm. Um, while it stalled over Greece, it stayed there for a few days. It was in September, and it was able to gain a lot of energy. At this point, it it, it brought up tropical-like characteristics, to which it was officially named a storm. It was Storm Daniel. Storm Daniel had tropical-like characteristics. It had wind speeds of around 50 miles per hour at its peak, and it moved south towards Libya. At this point, this is where the true um, damage in Greece, it caused $2.14 billion of damage. It caused 17 deaths, and that's not even the worst of it. It was until it hit Libya, which, as we know, or if you don't know, I'll explain it. It's a war-torn country. They've been in a civil war for a very long time, and this played a big role. The government couldn't do anything about the storm. A 50 mile per hour tropical storm that would hit the US, if it stalls and it rains a lot, it will cause a significant amount of flooding, and there will be damage and there will be fatalities, sadly, but not to this degree. I do believe we have, at least to an extent, a good enough warning system that we can prevent as many fatalities as possible. At least here in Florida, sadly in Texas, that wasn't really occurring. But in Libya, due to the civil war, they weren't able to evacuate pretty much anyone. They weren't able to put that many warnings. They put a curfew, and that's about it. Uh, it also just so happened that a lot of the infrastructure in Libya was also decaying at this moment, and there were two dams that were also decaying. So around September 10th to 11th, Storm Daniel, or as I like to, as some people like to call it, Medicane Daniel, Mediterranean hurricane. It's not really a hurricane, but it's a catchy name for a weather event. Medicane Daniel, it hit Libya. It struck Benghazi first, and then it made its way towards Derna. And at this point, it hit an arid climate that isn't accustomed to so much precipitation. And although the majority of precipitation occurred over Greece, a lot of precipitation still occurred over Libya, right? It just so happened that 16 inches of precipitation fell around the Derna area, and this caused enough flooding, or it caused enough water accumulation in the dams to burst them. The dams failed. There was two of them. I believe one was the Derna Dam, and the other one was the Mansour Dam. And this caused an extreme amount of flooding in towns that were just down slope from this area. In the end, $19 billion of damage occurred in Libya alone, and over 5,000 fatalities occurred here as well. So it was considered one of the deadliest storms or weather events that to occur in Northern Africa in general. So I wanted to bring this up because this just highlights the importance of being prepared, having proper evacuation systems in place, and having proper warning systems in place as well. It's unfortunate what happened in Libya. They just weren't able to evacuate these people, and because of it, more than 5,000 people died. Sadly, in Texas, it wasn't anywhere near as bad, thankfully, but there's still signs that we need to have progress. We need to invest in a proper warning system and better ways to evacuate people as well in case there is a system, even a small system like this, relatively small compared to a Category 5 hurricane. So, any questions from you guys? I know it's a bleak topic, but
Well, I will say that that 5,000 number death toll that hit me, and it's a number that we haven't really seen in modern history. Can't recall the last time that many people passed away because of a think about perspective is key here. Talking about what here in the States would be a mundane tropical storm, 50-mile-an-hour winds.
yeah,
And then again, to your point, it's the topography, it's the lack of preparation, the lack of a warning system. They have just the basics. They don't have the tools necessary to ride these things out. And it's horrific. That was
it
more of
is.
an observation here. Questions, I'll probably think of a few
I,
momentarily.
I, I, what I find more surprising is that I know some of our words, like in the English language, originate from like Greek and Roman, and huracan, for example, is a word from here that originated in like the Americas.
Yeah,
But I believe cyclo is one that originated in Greece. And it's
yes.
fascinating to see that although they don't experience hurricanes to the same capacity, I find it fascinating that they get their own like embryonic hurricane-like phenomena. It's fascinating. And it's awful what happens, but I think that that's what happens when we don't focus our funding on figuring out our planet. Like we've been living on this thing since the origin of our species, and look how it still surprises us,
Yeah.
and it's beautiful
To
in
put
its
It is.
horrifying way.
yeah, to put like a happier tone to it.
Hmm.
When I first found out about this topic, I was like, "Oh, Medicane. That's the coolest thing I've ever heard. I want to do something on it. I want to tell you guys about a Medicane." It turned out to be a very sad topic, but it's still very cool. It's a rare phenomenon that occurs every so often. The topic that Lewis shows is somewhat related to that. It's, in fact, it's very much related to that. It's a cutoff low in the Mediterranean that just gains strength for whatever reason, whether it be high sea surface temperatures or a lot of warm moisture coming in from the Atlantic and mixing with a cold core of this low pressure that just gives it a lot of energy. So it's a very cool topic. I know it was very bleak, but
Yeah.
it is very
Yeah.
cool, but something to keep your eye on.
I would add, it's not surprising in a way that there is no warning system for it. If these storms are that rare, that look at tsunamis. Tsunamis were something like that we didn't have a global warning system about until 2004 when the Boxing Day tsunami occurred, and then everybody decided like, oh, we need to get our shit together. So I, I'm hopeful that we learn from something like this and we don't let it become like a Boxing Day tsunami, and that we're able to develop a system and that we sort of have already for detecting hurricanes. It's been, I don't think that for the past 50 years, there's been a hurricane that forms that we don't know about, right? Like we've no, and so like we should be able to like help out in this, just integrating and tweaking it a little bit.
Yeah. Yes. I think for our case here in the US, we should be able to do that. I think most of the world should be able to do this. It's just in an unfortunate situation that some countries, some very unlucky countries like Libya have, that they
Yeah.
just struggle more than they should to really get these very important systems in place. I'm going to have to speed this up and end the episode unless we have time for maybe one more question really fast. No? Okay.
I think we can sign off here.
Awesome. Okay, so we're gonna sign off. This was 3 Degree Weather, uh, hosted by meteorologist Emmanuel Rivera, meteorologist Andres Sosa, and meteorologist Luis Dieguez. If you guys want to plug your channels real fast,
All right.
Andres.
I'll go first. I run the Weatherist page. I basically talk about memes, weather, adventures, but I also cover like sorry, weather topics in the contiguous United States. What does that mean? Everything from Washington to Maine, California to Florida. All of that is what I'm currently covering, and I hope to see you.
Awesome. And Lewis, real quick.
Feel free to follow me at 2580 Weather. It is a terrific source for weather information in South Florida. I am occasionally tracking tropics as well. Lengthy captions, informative captions at that, high quality graphics like the one you just saw in this episode. I'm one click away.
Awesome. Thank you so much. And I am meteorologist Emmanuel Rivera. Find me at Where the Skies Are Blue for your weather content. Thank you so much for following 3 Degree Weather, and we'll see you next time. Signing
All
off.
right.